Hello everyone. Welcome again to one of GL's webinars. This is our July edition of our monthly webinar, and we have an exciting topic for today. Today's agenda is focused on the MAPS platform that GL has, and more specifically the MAPS Protocol Core Network Simulator. So if you're not familiar with this product and its capabilities, this webinar is focused on giving you a little bit of an overview on that product, on the simulation capabilities, all of the networks, all of the protocols that it has been designed to help with and support. We'll also get in a little bit deeper into some of the new functionality with that protocol, with this product, with MAPS. Something we call our remote controller that basically can help control multiple MAPS nodes, and you'll get a flavor on how that works here as we get going. So thanks again for joining us. My name is Matthew Yost, referred to as Matt a lot by my friends and colleagues. I'm joined here by Bandon. He's going to be helping me out. He's our expert on the MAPS product. And I'll just get started with a couple agenda items and then an administrative comment, and then we'll get started. But the agenda for today is basically going to be a quick overview of our company, just very quick, a slide or two, if you're not familiar with GL, and then an architecture diagram of MAPS. And then we'll get into remote MAPS overview and how MAPS can help you with specific networks like LTE networks, TDM networks, and so forth to follow. So thanks for joining us. Let's get started. The company overview, just quickly to note here, if you're not familiar with GL Communications, we were founded in 1986, so we've been around for a little while, and we're located in the United States, in Gaithersburg, Maryland, which is about 30 minutes outside of Washington, D.C. Primarily, we consist of two divisions. One of them we call our engineering consulting division or services division, where we support local, state, local, federal government agencies, a lot of transit agencies in the local area around Maryland here. And our other division is our test and measurement equipment division. So this is what you as guests to this webinar are probably more familiar with, where we sell and market commercial off-the-shelf testing equipment for telecommunications engineers and technicians and so forth. As we move forward here, GL has a worldwide reach. We're located, our headquarters, again, are in Gaithersburg, Maryland, but we also have offices in Bangalore, India, and Shanghai, China. We have a very highly capable and experienced team of representatives, too, throughout the world. Many aren't even shown on that diagram that I just went through there, but these representatives can work hand in hand with you if you're more comfortable with a local representative, and they do a very good job of interfacing back to us at GL and expressing your needs and your interests. So we've got good relationships with a lot of representatives throughout the world, but most of our sales, just to take a note, are direct from our headquarters here in the U.S. So when we're looking at how GL is positioned in the test and measurement market, we've got a lot of products that and a lot of solutions across the board here. At a high level, I would say that we can test in an intrusive manner and in a non-intrusive manner. So we can monitor your network in many ways that are non-intrusive, or we could inject and be intrusive. So protocol simulation, packet generation in the IP world, and things of that nature. So with network testing, again, we've got products across the board there. In the wireless domain, we support a lot of LTE, VoLTE, GSM, etc. Type products, fiber, TD and traditional TDM with T1 and E1 products. And specifically, we have addressed the need to test and monitor true endpoints to the network. So we do a lot of voice quality, video quality, data quality testing from mobile devices from an endpoint of a network. So an IP phone, a mobile device, and so forth. So we've got a lot of products across the board there that can address either endpoints, devices, core network elements, or the network as a whole. So let's get started with the MAPS overview, and I'll just jump right in here and give you just a quick overview of what MAPS is. So the question is, what is MAPS? You maybe have heard that term. Our GL engineer or technician has mentioned it before. MAPS stands for Message Automation and Protocol Simulation. So this is our GL's offering to the marketplace for a simulation product. So it can be either a SIP simulation product, an ISDN, PRI simulation product, LTE, and so forth. You can actually see here on our diagram, on our screenshot, that we've got a lot of different protocols covered within this entire MAPS framework. So I'd like to say that MAPS is a generic framework offered by GL for generating and simulating protocol messages, mainly needed to set up calls, sessions, and so on. It can also focuses on the protocol messages for setup and teardown of calls and sessions, but it also has the ability to generate voice traffic. A lot of customers need that, and so forth. So MAPS consists of basically 3 layers, and I'm going to talk about those briefly here, and then on the next slide I'll get into them a little bit more. But scripts, messages, and profiles. So with scripts act as basically the state machine for the protocol, and it's the logic of how the messages are given at any given time during the protocol sequence. So for instance, in SIP, when an invite is received, what does the MAPS product, what does our simulator do at that point? Does it try to send a 100 trying message, a ringing message, or what? So the script dictates that, dictates the state machine of the protocol messages. And secondly, we have messages, okay? So the scripts are dictating what messages are sent at any given time. The messages and the flexibility with the messages are available within our MAPS product as well. So it's basically, we give you, off the shelf, we give you a very generic message template for all the messages within the given protocol. For instance, we're showing here an invite message on the screen. So we've got the basic building blocks of that invite message already defined. If you'll see here as we move forward that MAPS gives you full flexibility. You can actually change headers. You can change different things within that message if you want. But we give you the off-the-shelf basic message. So the message is used by the script to initiate these calls and sessions. The profiles at the 3rd layer, the profiles are where sort of the customization would generally happen. Now, you as a user, if you're slightly more experienced or more willing to dive a little deeper, you can change the script state machine if you want. You have full access to it. You can change the messages. You can change a header within a particular message to make it slightly, let's say, oddball from the generic protocol message. Those are given to you. The standard ones are given to you. 90% of our customers don't even touch the scripts or the messages part of things. They're dealing in the profile area. And the profile area of MAPS is where all the customization happens. For instance, the exact contact information. Here we have like 12345 at sip.carrier.com. So we're giving you an area here in our profiles where you can define the very specific things about that particular call or session, or all of the thousands of calls or sessions. So that's very easily defined there. So, call 1 maybe 12345, call 2 maybe 12346, or so forth. So those types of things are all defined within the profiles. to get into the 3 layers a little bit more here on the next slide, and I don't want to dwell on it too much, but again, we're showing the scripts, the messages, and the profiles, and I'm just going to basically read to you this slide because this kind of gives you a little bit of an understanding of how these things work in a little bit more detail. Each instance of a script corresponds to a single transaction or a call or a session. So if you place 500 calls in parallel, you actually do have 500 script instances running. So in parallel, you've got 500 script instances running. Each script can be unique if you'd like, or it can be the standard off-the-shelf script. If you place 500 calls in series, so one after the next, it would be the same script being executed 500 different times, okay? So it kind of gives you a little bit of an understanding of how that script works, the architecture-wise. When we go over to the messages now, again, these are the templates provided for the actual call structure of the message, for the actual structure of the message. So you can actually see down in the screenshot below that the one on the far left is the actual script. The one in the middle is the script again, but I'm highlighting the invite.txt message. It's hard to see there, but so the script calls the message and it sends that message. And that message again is sort of a standard message at this point. Now, when we go over to the far right into the profiles, each invite message that gets generated with this protocol simulation product, this MAPS product, you do have to have some unique characteristics to that message. So that's where all of the custom stuff goes into. So the user identification and so forth. The IP addresses that it's calling, things of that nature. Anything that's dynamic within calling is located generally within our profile section. So that gives you a little bit of an understanding of how our we call them the 3 layers of MAPS works out for us. Let's go on ahead here. Again, I'm at the sort of overview level of MAPS. Bandon's going to take over here in a minute and give you a little bit more detail on how these things work. But I'll spend just a second here. MAPS is fully capable of generating traffic, as I mentioned before, and this can be voice, video, digits, tones, and so on. This picture here on the right-hand side represents that in some way. It shows you some of the different traffics that can be generated. And then we're just giving you a standard list here of all the protocol, codecs, I'm sorry, that we support within the MAPS product. So pretty a long list there of codecs that we support. Now, on the next slide here, I'm going to introduce just again at the top layer here. If you're interested in simulating SIP traffic, for instance, SIP generally is on an IP interface. So we have to couple hardware at times to our MAPS product. So the MAPS product is the protocol simulator, but at the hardware level, we have to have something there to do it. So with SIP, for instance, it's easy. We use the Ethernet port maybe on the PC. If we need to simulate many thousands of calls, we have some high density cards, specialized cards that we can put into our platform. If we're simulating, for instance, again, ISD and PRI on the T1 world, we can marry our MAPS product to some of our hardware that you may be familiar with. So we've got T1, E1 products, OC3, OC12, and so forth. So there is a small relationship between the MAPS software framework and the hardware, and it very much depends on what protocol you're trying to simulate there. So that's all I wanted to say on that. And that sort of concludes the overview of MAPS. I hope it helped you get just a sort of an understanding at a top layer here of how MAPS works. Bandon now, I'm going to turn it over to Bandon, and he's going to give you a little bit more deeper dive into MAPS and more specifically some of the remote controller capabilities within it. So with that, I will turn it over to Bandon.
Thanks, Matt. It was a nice introduction given for MAPS and its features. From here, I will take the remote maps feature, which is used to control multiple nodes from a single point. Before we get into the deep into the remote maps, let's see where and all we can use the remote maps and how it will be useful. So whenever we do this network interface testing, there are multiple ways of testing the DUTs. So for example, it can be a single interface simulation. As the picture depicts, the RNC is a DUT and MSC is simulated by GL. So it is only testing the IUCS interface. One more is the multi-protocol, multi-interface testing, where we can see a single node is connecting to multiple interfaces in the network. So in this case, we have to deploy many nodes to complete one end-to-end scenario. So for example, if you consider either UMTS or LTE, it involves multiple nodes where the messages has to travel multiple nodes to do its respective jobs and get the call routed to the other user. So in this case, it is quite difficult to maintain all the nodes because we have to log in and see what's happening there and other such problems. So remote maps helps in such situations where user will be able to control all different nodes from a single point. So this is the architecture of the remote maps, where we can see that we are depicting 3 different networks which are very much used now, like 2G, 3G, and LTE. It is having a core network which is very versatile, like it is very big in terms of the number of nodes which are involved in routing the call or for this LTE packet switch domain and the circuit switch domains. So in this case, the remote maps helps the user accessing all different nodes from the network from a single point. This picture depicts that we have a listener which controls, which communicates with a client and a server. This is basically a client and a server module. So in the remote maps, user will be able to connect to different nodes in the network. And as well as in the remote maps, multiple users can be created in order to control different test scenarios depending upon the requirements. So one flexibility is from a single GUI, we will be able to control multiple networks or multiple network elements in the network. So it gives you many flexibilities. We'll go through few features. It is a remote control GUI. It can remotely control all the network interfaces, as I was explaining. So it is like it allows you an integrated testing of different networks in the different domains. It can be a wireless or IP or even analog. It is very much suitable when it involves multiple network elements, so that it gives you a single point of operation, and it provides you interoperability functions. And one more good feature is remote maps provides access to all the functions which our maps with a GUI feature provides. So maps is a one framework which is independent of the protocol stacks. So basically the remote maps is a client server based communication which is facilitated through a TCP IP protocol. So here we call it as a listener, where it is an entity where it lists out all the products which are being installed on a particular server, and it sends back all the information to the client, from where user will be able to control the multiple servers. And basically, like there is no limitation of how many remote client users can be defined to the server. And basically, like we have a concept of admin user and the testing users. So admin user is the one who will be able to control the complete network architecture. Say for example, starting of the particular node, setting up different parameters and so on, which is required to establish a communication, like basic transport communication and other things. And it is based on the single license server option available for controlling different maps licenses, as well as the client. It is depending upon the number of users. And it will be useful in generating both the control plane as well as the user plane messages. So here we are trying to depict that. So each server will be having multiple applications installed of maps, okay, and each server will be having one listener. So this listener will list out all the products which are being installed on that particular server. And client is a one system from where a user can connect to a server system through a TCP IP. So basically in this diagram we can see that in the admin user, he is connecting to a different protocols, SIP, CAS, LTE, IMS, and so on. Similarly for the other users, as well as user 1 and user 2. So now let's see how the communication happens between this client and the server via listener. So we have one client system where we are installing this remote maps client. Okay, and we have a server which is having the actual maps product installed, which is nothing but where we are trying to simulate, or we are trying to one particular interface, or say for example maps EGTP. So that particular product is installed in one server system, and we will be running one listener in that particular system. So now whenever a client maps client is trying to connect to a listener, okay, once it is connected, it gives the list of all the maps which are installed on that particular server. On that particular server, the installed products with a particular licenses. Now once the client PC get all the products which are installed, then the user has the flexibility to select which protocol he wants to work on, because a server can have multiple protocols installed. So now the user selects the protocol and he will try to start the map server. Once the user selects and starts it, the listener will try to invoke a map score. In terms is nothing but he is trying to start the maps application. Then the listener will provide back the respective information about the core application, which can be IP and the port number of the maps server. Once this handshaking is done, then the communication is established between directly the client system and the server system. Now the communication is directly between the client system and the server system, and user will be able to do all his protocol simulation activities. Yeah. One more important feature is whenever we talk about remote capability, multiple users want to work on the same network. So in this case, we create a one user who is an admin, who has the capability to create the testbed setup, start set, and create multiple users. So he will be able to create the multiple users and allocate the resources based on the testing criteria. So admin user will create the multiple users and allocate the resources to each user. So once the multiple users are created, so each user will be given a resource and he will be able to conduct all the tests which is required on the same network. So this is the remote maps GUI, where we can see that this is for the admin user. On the right hand side we have for the user, where for the admin we have the controls for starting this test bed, editing and other things, whereas user 2 will not be given any such flexibilities. He can only execute his test cases on the provided resources. Now let's see how it can, I will just take an example of LTE network. So this is the client application where we have created, we are trying to connect to multiple servers. Say for example, different nodes like eNode B, MME, HSS, or the PDN gateway. So user can connect to multiple servers from a single point, which is nothing but a remote client. So now this is LTE network, where we have different interfaces can be simulated. So say for example, we are seeing this GL logo. This is all are supported by GL. So in this, I'm just taking a simple example of simple LTE network, where at the last we can see a video how this LTE network can be simulated using GL maps and with using of remote maps. So in this particular scenario, I'm just trying to depict that from a single point, we are showing two different views. One is MME, the call related to the MME, and the other window is showing the STW related. So this is from the single GUI. We can just select this drop-down window where we can select the different nodes of a network. So now, till now we have talked about the IP domain. Similarly, the remote maps can also work for the TDM. So it's quite similar to the IP, whereas we will be starting the listener where our T1E1 hardware is connected. So PC1, where we have the T1E1 hardware. So we are going to start the maps listener in that particular system. In the similar way, the maps listener is going to give all the information towards the remote client. So in the PC2, I'm depicting two users. One is the admin and other one is the user one. So admin is the one who creates the testbed and set up profiles and start the testbed for all the users. So we can have multiple users, but whereas only admin has the privileges to start the testbed. So only user 1 and user 2 can connect from a different system towards the same maps server. So he will be able to execute his different test cases depending upon the resources allocated to the each user. So now let's move on to a new feature where maps will be able to generate the bulk call using the CSV profiles. So basically we have two to three different varieties of generating the bulk calls. One is, as Mike was explaining, we have a profiles, which is a GUI based, where user will be able to enter his specific information related to each call. So for example, we can see here, we have a different parameters like IMSI, TIMSI, calling number, call number, which is related to the subscriber information. The one way of doing is we can have a profiles where it can be a limited version in the profiles, which is mainly used for functionality testing. Whereas it comes to bulk call, user can have a CSV profile. He can generate a CSV file where he can write down up to 20,000 subscriber entries. So which will have a unique values for each of the what we can say, each of individual parameters like IMSI, TIMSI, LAC, and so on. So this will provide an user where he can massively generate calls on the network and test his core network. So this is one new feature where user can create a bulk call using the CSV profile. One more is he can generate the same amount of bulk calls using auto-generated users. So here there is no CSV file, there is no profiles. We have one section in the testbed where user now the user can provide all the starting parameters of the individual parameters. So for example, the starting value of IMSI, MSISDN, IMEI, and so on, whichever is required for the call generation or different parameters required in terms of differentiating the calls. So all that information can be given in the testbed, and internally the maps will handle. Starting from this value, it is going to be auto incremented inside the scripts. So whenever he places a call, on the right hand side we can see that it is generating the IMSIs on all different values. So all the calls have the different IMSIs. It is nothing but we are generating a bulk with all the unique values. So we are already succeeding up to the 12 lakh subscribers here. The next feature is from the maps, we can send the important records to the database. So, for example, the test related parameters like when it is started, what is the call number, calling number, all the important results can be sent to a database, and then it will help the users to analyze it later. So, whatever the simulation test cases the user is going to simulate using the maps product, all the reports can be sent to a database. Yeah. The next important feature is the CLI for remote control. So till now we have discussed about the GUI version. So even maps provide for the user where he can control the complete protocol life cycle using the CLI part. The maps client provides a different language supports where we have this Python, Java, TCL, and so on. So our GLS scripts, we can write a wrapper where using these languages, user will be able to simulate his test cases. So it will allow you an interface where this TCL, Python, Java can communicate with our maps client, and it will be able to simulate the different scenarios in the network. Going ahead with the same concept, we are trying to depict all different simulation tools where we can see that it is IP signaling, whereas TDM is involved. So we have a different clients from where the user will be able to do his testing on the network elements using this automated test client. So we will be providing an APIs from where user will be able to design his test cases. So there are two types of APIs provided. One is low level and one is a high level. The low level APIs provide you very detailed information like the message, which message has to be sent, what is the parameters to be fed to it, and so on. Whereas in the high level API, we are just going to provide a place call or answer call, terminate call. So these are the high level APIs where user will be able to write his own scenarios using these APIs. So coming to the system integration, we have already tested it with a test shell where it will be able to control the multiple elements like different maps elements like 3G, 4G, TDM, and VoIP. We have also tested it with the HP UFT. So given like whether any third-party tools where it supports the Java and Python, we will be able to integrate with our tools. So it will provide you a more flexibility in terms of integrating with system integration, where user will be able to create his own scenarios using these clients. So this is about the CLI part and the new features. Okay, we can just go over a live demo video where I will be demonstrating this how this remote maps works in terms of simulating the different network elements. So I'll just play a video which is a very short of 5 minutes. So we can just go over the video. So in this video, the first user is going to start the listener. He is going to provide the server IP address and the port from where he is going to listen. So now he has started the listener. So one flexibility is whenever we close this, it will write down to a file which all the protocols are already installed and licensed in this particular server. Okay. Once the listener is started, user will be able to connect from the client to this particular server. So this is the client application where user will be able to add a different servers. So for example, in this video, I'm trying to demonstrate the LTE network. So let's connect one by one to the LTE network elements. So let's start with the E node B. So here user will be able to select which node he is trying to simulate. So he has to give a server name and the respective IP where the listener is started in a particular port. And now these clients, we are just adding it for the admin user. MME. We'll try to add all the LTE network elements one by one. So we have to add the serving gateway. So as you can see that there is a difference between the E node B, MME. E node B and MME are connecting to the same server, whereas this HSS is connected to a different server. You can see the server IP and the port. Similarly, the HTW is on a different server. So from a single client, I'm trying to connect to a different servers. Yes. So HTW and PGW are running on the same server. So now we have added all the client elements, like we are trying to connect to a different servers from a single client. So once all are added, I'm just starting all of these clients. So these are all connected to our server systems. So this is the testbed setup. And one more important feature is user has to register his resources. So resources are nothing but the profiles. So now for each server, we are trying to register the profiles. So once they are registered, we can start the test bed. So I'm just clicked on start all so that all the entities will be started at once. So now we can see that HTTP link is up. And this is the call generation window where we are going to initiate and call. We can see that script name and the profile. So I'm just going to start on the first script. So we can see that the call is initiated and we will be able to see the flow between E node B and MME. This is the MME where we will be seeing the call flow between multiple network elements. If I go above, we will be able to see that E node B, MME, HSS, and HTW. Whenever you click on a particular message, the decode of that particular message will be shown. So now, through the user event, I'm going to detach the call. We can see that result is updated as well as the call flow is updated.
Okay, thank you, Bandon. Thank you very much. That was a very good explanation of how some of our new features and maps can help people. Before Sanjeev collects some of the questions that we had, I had just a general question for you that you can probably help some of our attendees with. You know, I can see that some of these features, some of the ones you talked about, especially like the CLI and so forth, can really be integrated into a test bed by a customer to maybe do regression testing and things of that nature. Is that what we're seeing some of our customers doing with this? Is that where you're seeing some of that?
Yeah, basically like this particular CLI is used for functional testing as well as they try to automate the complete process. So if they have multiple test cases, they can have these multiple, using the APIs, they will create the multiple test scenarios and they will try to automate it.
Okay. So for automation, of course, automation is very nice to have, of course, in your testing environment, as well as regression testing, repeating the same test. Maybe maybe you're responsible for a network element, a router or so forth, and you want to a new firmware version for that router comes out, and you want to repeat the test again that you did before. You can, of course, save all of that and do an exact replication of what you previously did to see if results changed in any way. Is that some of the? I know some of our customers are doing things like that. I don't know all of the details of it, but you probably know better than me. But I suspect that that's where some things are going with these CLIs and so forth. Is that right?
Correct, man.
So
yeah, we have a question from a customer. He's asking maps came preloaded with some scripts. How can we load them into the GUI? If we have only one Maps HD server, is it typical to open two instances of the GUI for sender and receiver?
So basically, like, no, we don't need to invoke two different instances for generation and reception, because we are going to handle both generation and reception in a single entity. So it is depending upon the user whether he needs to have a different scripts for generation and reception, and we have the flexibility where user can configure what scripts to be loaded on the reception of each message. So that flexibility is there, but we don't need to invoke multiple instances for generation and reception.
Okay. So yeah, a single instance of maps can be a generation side of a call or session, or a reception side, depending on your viewpoint there and whatever you want it to be. You know, there is a need at times to have multiple instances of the maps, and that may be for geographic separation or and so forth. I mean, Bandon, there one instance of maps cannot handle every test scenario, correct? I mean,
yes, yeah, definitely. Yeah. Like, I mean, it depending upon the use cases. So if they want to connect to two different networks from two different applications from a single server, yes, right, they can invoke the multiple instances of maps where they can connect to multiple servers.
Right. So I mean, it is very dependent upon your test scenario there and your lab diagram or your network diagram. And you know, we can help you design the platform to meet that.
He has another specific question, like with Maps HD SIP and RTP generator, can we send our own video files? And also, is there a way to remote access the Maps server?
Yeah, like basically, like this remote access is possible. Regarding this video files, we uses our proprietary HDL format in case of whenever we transmit these video files. So
yeah, but we can take a video, correct, and we can convert it to our through means we can convert it to our proprietary file and send it out. So, I mean, that can be done, correct, Bandon?
Yes.
We have another question. Yeah. He's asking, is it possible to generate attacks on GTP layer? Yeah, I mean, he's basically asking explore the vulnerabilities on the GTP-C by customizing the header.
Whether it is going to be on the control plane or the user plane is two different scenarios. In case of control plane, we can change the header because we have we can introduce a different kind of what we can say, like we can change the hex dump depending upon the values they are going to provide, so it will going to corrupt the messages. So we have that flexibility. In case of user plane, like currently we are working on the simulated based HTTP traffic, where we will be playing back and pre-canned HTTP files. So whatever that file is going to contain, we are just going to play it back once the tunnel is established. With respect to control plane, yes, we will be able to change the contents of a message using the message editor as well as changing these hex dumps.
Correct. I mean, and further to that, Bandon, I mean, we can change the message headers to anything you want. We can also change the script as well to, you know, possibly simulate an attack in some way with repetitive messages being thrown and so forth. Is that, I mean, both things can be changed to try to simulate this attack in some way, I assume.
Yes.
Yeah, there is one more question. Yeah, he is basically asking, can you record a PCAP?
Yes. I mean, record PCAP. I have to understand what that exactly means, but we have, yes, we work well with Wireshark and a PCAP file. We have little utilities that can convert from our our proprietary file type to PCAP and vice versa. So
he's asking, can we import from a PCAP file?
Yeah, basically, like, we cannot directly import the PCAP files as of now. We are working on that utility. Whereas from a PCAP, we can just extract each messages, and that can be used for the simulation purpose. So there is a utility which converts each PCAP into our proprietary format .htl. The same templates can be used for the simulation.
And that would maintain the timing and so forth. Is that correct, Bandon?
In case of like simulation, the timing cannot be maintained from the PCAP, whereas it depends upon when you are going to start your scripts, because we are just going to use that message template.
Okay, so the message template side of things. So if you have a PCAP file that has a specific message in it with that template, we can start using that. Is that what you're saying within our script?
Correct.
Okay, I understand. I hope that's clear to Jeff.
He's again asking, what about the message flow to use in a script?
Okay, so I think that's what we're referring to as our script when he says message flow, I think. So, Bandon, why don't you readdress what you kind of just said there on how, yeah.
I think there are two different scenarios. One is we are going to use the same message template which are there in the PCAP. So, for example, attach request is a one message. If it is there in the PCAP, we can just extract that attach request message, convert it to our HDL, and use it within our scripts. Within our scripts, we are going to send the same message. That is one thing. One more scenario is where most of the customers are interested in simulating this flow using the PCAP. So we have to generate this flow using the PCAP. That utility we are currently working on.
Yeah, that's fine. I think it answers his question.
Yeah.
Thank you, Matt. Thank you, Bandhan.
Well, thanks a lot, everybody. I appreciate it. Hope you had a good time with our webinar today. And again, just to repeat, we will be posting it on our website so you can review it, and you can get a hold of us at any time. The easiest way is through that email there at info@gl.com, and you can even reference this webinar if you have specific follow-up questions, and it'll get to us, to Bandon and myself. Okay, thanks a lot, everyone. Bye-bye.